This is Bill Bittner. Today is Monday, May 11th, 2020. Good morning, good afternoon, good evening. Today's session is a little bit different. This was actually part of a presentation I had done when ZVM 6.2 first came out, right? And that's the release that introduced SSI and LGR, really part of a session that I called Increasing the Endless Possibilities, right? So it was a little bit about the background of how we designed and developed SSI, then also some of the newer things that you could do with it. Some of that material we covered in earlier sessions here in terms of SSI and LGR, live guest relocation, what makes those different, how do those work, and so forth. But part of that session was also what I'll show you today, which I've broken into this new presentation, which is just some different usage scenarios, right? So ordinarily, when we think about SSI and LGR, we're thinking about the ability from an availability perspective to address planned outages, right? So typically, the most common example is I want to apply service to the control program that requires having to re-IPL ZVM. So how do I address that? But as you'll see that there's some other things that I've collected over the years in terms of what we might want to do with SSI and LGR that lend to that. All right, so just a reminder, or for those that are listening to this recording that didn't see the earlier sessions, I encourage you to go back and listen to them. But remember, SSI or single system image had been a price feature of ZVM, is now included in the base starting in ZVM 7.1, and allows you to connect up to 4 members or 4 ZVM systems. Those can be LPARs all on the same server or on different servers, right? They communicate to one another through CTCs. Most of the disk you see in the middle there are shared disks, with some private disks such as paging space and a res volume and so forth for each of the ZVM members or LPARs. We use a single user directory. Each member would have its own object directory, but we recommend that there is a common source directory for that. And this environment obviously allows the live guest relocation, the movement, Linux virtual machines, moving between members while they're running. So I'm going to go over 10 different scenarios of how we might want to use SSI clusters and LGR, right? And I would use this and some other material quite a bit when SSI first came out, but I still do that at times where we'll get into these discussions where the customer says, well, we want to do SSI. And I'm like, well, what do you mean by that? And they're like, well, we don't know. We hear it's good for availability, right? And so wanting to talk through how all they might want to use it from that perspective, but then from other perspectives as well. Part of what comes into the dialogue here are things like, how many members should I have? From an availability perspective, 2 gives me redundancy, right? But there are cases where I want 4 or 3, right? So let's just walk through these scenarios. Okay, so the first one is that common one, the flexibility for plan outages. So I may have an environment here where I have 4 members and I want to apply service to member A, right? So to do that, I'm going to use live guest relocation and I'm going to move the workload from member A off to the other 3 members in the cluster, right? So this is one of those places where I'll talk to clients about the number of members, right? Because if you think about this, if I only have 2 members, that means each member has to be able to handle all the work of the other member, right? Whereas in this case here with 4, I can distribute the workload so that there's a 1/3 increase to each of those other systems that are out there, actually less than that, right? And so that might be easier to be done from a performance and capacity perspective, as opposed to having all this workload just go to member B there. I think we talked a couple weeks ago when we talked about performance here of this as well, and that in some cases I don't have to move all the workload, right? So like the TCP/IP stack, the RACF virtual server, there's already one of those on all those other members. I don't need to move those. I can just shut them down. Likewise, there may be things that are being clustered at an application or database level where there's already a copy of that database on another system, and I don't need to move that. Okay, so I've moved the workload off of member A. I can then shut down member A, bring it back up, and then move the workload back into member A. I've now upgraded, added service to ZVM, and the applications, the Linux guests, from their perspective, doesn't recognize that, right, or wasn't impacted from it. And so that's goodness. All right, so that was a pretty common one. The next scenario one is when I talk about testing at current levels, right? And so one of the challenges at times, especially as systems got bigger, was how do you line up testing for everybody all at once, right? So once upon a time, we might have upgraded a ZVM system over the weekend and asked everybody to come in and do testing to validate that they run okay on this new level. Now, part of that's because as mainframers, we're paranoid, right? We want to make sure and validate everything. But when you think about it, we have a pretty good track record, pretty good history of having forward compatibility, right? But still, we want to do some testing here, right? And so the idea here is, in this example here, again, with 4 members, member A, you see, has a more current RSU, and we're going to want to test these different workloads there, right? And it may be difficult to line up all those different applications, 2 through 10 there, to validate on this new level of the ZVM hypervisor at the same time, right? That's one of the challenges we run into as the systems get larger. And it's one of the things that I sometimes talk to clients about in terms of they'll be looking at, how many members or how many clusters even do I have? And one of the things I talk to them about is how many lines of business do you want to have in one cluster or even in one ZVM system? Because while we can do things technically, many of you know this better than I, lining people up from a planning perspective can be a bigger challenge at times, right? Trying to get sign off from different business units that, yeah, we're going to do a changeover this weekend. And you might get a scenario where all but one of the business units says, yeah, that's fine. Well, then what do you do, right? So anyway, from this testing perspective, what I can do then is with LGR, I could one by one move things around, move them into that member A. So it's just as I did with 2 there, and we'll do with 3 as well. And we'll do this testing to validate that each of those runs fine there. And if it doesn't, we can simply move it back. And so this gives us a little bit more control at methodically testing and rolling things out, right? And then if there is a problem, we can roll back the methodology we showed earlier. We could roll back those changes in member A if that was really required, right? So it gives us a different approach to testing and validating some of these things there, right? Also allows us to match things in different environments, right? So I may have some scenarios where I keep one member, one service level ahead, just so I can test things out and validate things of that nature. So that was our second kind of scenario. This next one I used is for customers that originally I used a lot when 6.2 first came out, right? Because they were curious about SSI, but they had already built their environments large enough to deal with what they had going on. I now also have used this or started using this again back when 7.1 came out because SSI was free. And so now they don't have to worry about the price point for it. They can just have it there. Okay. Now, we'll often talk in the industry about server sprawl, right? And that's one of the things that makes virtualization and consolidation on the platform so attractive, right? And that's that idea of every new application that rolls out, we're pulling in a whole bunch of servers, right? And so you may have a database server and a WebSphere server and maybe a separate HTTP server, right? But you don't just have one triplet, you probably have a pair for redundancy. And then you have a development and test and maybe a quality assurance set of those as well. And so you end up with this hundreds of servers in the racks that are out there in the environment. And so with that, we want to do that in sort of virtual raise floor up and lay it down on top of ZVM. Well, it's so much easier to generate and create new virtual machines. But with that, you can get what we call virtual server sprawl. And so things tend to grow and grow. And so there are scenarios where we want to expand our single LPAR maybe into multiple, right? Some of that could be we're just hitting the limits of ZVM, right? Or it may just be another thing of the risk management, wanting to have that many virtual machines in any one ZVM system. There may be also scenarios for software licensing. While the IBM Passport Advantage products can be licensed with subcapacity under ILMT, not all the vendor products can be, right? And so there are scenarios where we want to have separate LPARs for that. So what we would talk about with some of these customers was this idea of going to a new release, whether it had been 6.2 in the past or now 7.1, where we're going to set it up to be SSI ready and configured, but we're going to run with just one member in each of those clusters. Right, so in my example here, I have three different LPARs, or what had been three different LPARs, one for production, one for test, and one for development. Right, and so I'm going to create three clusters. And so this is one of the things I often talk with clients. I'm a big proponent of having separation between production and non-production, especially another way of phrasing that is mission critical work and non-mission critical work. Right, and you can get into debates about how strong is the separation between members in a cluster and things of that nature, but experience just tells me that there's more advantages to separating them in different clusters than it is to combine them, right? So that's why in my example here, I'm going to go with three different clusters and set them up accordingly, right? That also gives me experience. I may do this initially with the development or the test ones before I do that with the production ones and get some experience on that. And then what I can do is, as that virtual server sprawl starts, as the systems are growing or increasing in size, or I want to take advantage of some of the other things of SSI, that's when I can start spinning up a second member, a second LPAR for each of these clusters. And I could continue and go further and maybe add a third or a fourth member, depending on how large things grow, how heavily I want to use SSI and LGR, and also to some degree, what hardware do I have it available, right? So this is a way to sort of naturally grow into clustering technology. And I did have some clients that did this and grew as they started to hit the limits of ZVM, right? The resource limits in terms of processor or memory, they would just start spinning up more members, right? That's one of the reasons why some of our clients have asked for more than 4 members, right? And so that's a candidate on the list. Okay, that was another scenario there. Now, this next one I think we talked about in another session, but I'm going to go over it again because I think it's worth spending a little time on. And that's what I call production with protection. Right? And so what often happens in our world is new applications will be getting refreshed or updated. And our clients will do a lot of testing, but sometimes their testing isn't perfect. Right, and so they've rolled out maybe an update or maybe it's a brand new application. They've done some testing, but when they put it in production and mix it in with all the other production workload, they suddenly find the system going to 100%. Now, that may be okay, right? We've talked in the past about how IBM Z and Linux One machines can run at higher utilizations. So that doesn't necessarily scare us as technologists. However, often there's management and other people looking at statistics and they're like, whoa, what's going on here? What's wrong? Why are we running so hot? And in other times it actually can cause problems, right? Where a misbehaving application can have some impact on the other workload in that LPAR, right? Now we have ways to tune that and to address that. However, it still can cause a certain level of stress for people that we want to avoid, right? So what we're going to do in this environment is what I call 2 production members here, right? So 2 for redundancy and 2 what I'm calling pre-prod, or there's probably a better term for that, but I couldn't find it because it still really is production, customer facing, client facing workload, right? And what I'm going to do is the proven applications, so the applications that aren't changing, they're going to stay up in my production LPARs or production members of this cluster. And then I've kind of purposely created the member C and D, their boxes to be a little bit smaller, right? So their LPARs perhaps have a little less access to resources, right? This also protects me if this new application, when I place it out there, if it starts running amok or running away, it has less resources to consume with that. Also, it's isolated from those other applications, and I can have even better isolation and control over that workload, right? And maybe I let the workload run there for a week or however long it takes to prove that it is going to be perform as we predicted or how we expected. And so environments where I might use this more are where I have very unpredictable applications or perhaps very unpredictable application developers and testers, right? So anyway, I can have them run there for a while. Once they've proven themselves, we're going to move them through LGR, or we could log them off and log them on up in the production environments, the members A and B. Now, I know I just said earlier that I don't mix production and non-prod. I consider all of this production, just different levels of that, right? And so I had some clients that utilized this just to get better control as new applications were getting rolled out, right? One client in particular that comes to mind, it seemed every time they had a new refresh of their one application, we would end up with a crit sit, right? Because they just were doing an awful lot quickly and rolling it out without testing, right? One of those scenarios where they didn't have time to test, but they found time to have a crit sit, right? So we want to avoid that. This is one of the ways to help control that. Okay, so another place where we can use SSI and LGR is in managing resource distribution. Right now, ZVM on IBM Z and Linux One has a rich history of being able to move resources to where the workload is, but there are times where we want to rebalance the workloads as well. Right? And so I may have a workload here, and maybe over time it starts out balanced, but over time it grows imbalanced. Maybe I have more database servers on one side. Maybe I'm starting to roll out containers. Whatever the case is, the one LPAR may start getting bigger, having a greater demand than the other LPAR. Now, if these were two discrete ZVM systems, so a non-SSI environment, I could move virtual machines from one to the other, right, the old-fashioned way. But that requires identifying them, recognizing them, and the resources that are involved with them. It means taking them out of one directory and adding them into the other directory, which is a place that's easy to make a mistake, and a mistake being costly. Whereas if this was an SSI cluster here, I could just log off and log on the virtual machine and move it that way. I don't have to go making changes to my directory. I can far more easily move the workloads around. And more importantly, if I make a mistake, if I don't get the perfect balance, I can move things around again. Right? And so do that a lot easier than I could in the past, where I'm managing individual ZVM systems there. Right? So that's a key advantage there over running in a non-SSI environment. Okay. So a consistent test bed for stress tests, right? So part of this came to mind with one client that I went on site for a crit sit, and it was one of those scenarios where we were rolling out a new application. They were having trouble getting the testing done and getting good performance from it. And one night it was interesting. We're like, well, it's really weird that this application goes against this one database, and it was really the WebSphere environment that was getting modified, and performance was horrible. And looking around, I noticed, well, this database that it goes to is really busy. You know, one of the other folks at the client said, well, that database is serving 50 other applications. I'm like, well, is that how it's going to really run? And they're like, well, no, but that's how we have things set up in test, right? And so part of what I found in that experience was, and especially in their environment, from night to night, that database could be serving different numbers of applications. And so it became very difficult to do apples to apples comparisons as we would make changes to the application to see if it did any good, because it wasn't consistent, right? And so we want to do some things there, right? So we want to have a consistent environment. What I'm going to show you here is kind of a different view, right? So it's a non-production scenario, but we're going to have 3 different members in my cluster. Now, maybe I would split up unit test and component function test, or have a different kind of test group in there as well, maybe a system test, and have a 4th LPAR. But let's assume for now that the thing that I'm testing or rolling out, again, has a database, WebSphere, and HTTP. So I have these 3 Linux virtual machines that are part of this environment. And maybe when they're actually being developed, my developers are using those systems on their development member. And maybe it has 8 shared IFLs running there, right? And when they have it to a point where they think they're done, then we can move those 3 virtual machines over into the CFT environment, and CFT can run their tests against them. Now, you see an arrow with the pointer going both ways, because this might go back and forth a few times, right? CFT may find some different things there. Development may fix them. It's one of those things where developers don't have to necessarily ask, well, can you tell me about the environment you ran in, because it's the environment they were using as well. And so it does take some coordination, but it also eliminates duplication of resources and also eliminates some confusion as to what is what, right? Because it is the same system. Now, after a while, we get all the bugs worked out of there from a functional perspective. And then maybe we move those three members down to do our performance testing in yet another member. Right? Now, you may have noticed that these members are configured differently. Right. So my test environment member B, that's going to have 16 shared IFLs, right? So it's just some numbers I've made up here, but typically my test environments are going to require more resources because I have a whole bunch of different things going on there to some degree, some higher levels of overcommitment of resources. So I want a bigger LPAR there, a bigger member. And then for my testing, I'm going to actually have 3 dedicated IFLs. So I'm not putting a ton of IFLs in the mix here, but it's going to be dedicated so that it's more consistent from the performance perspective, right? So it's not as influenced by what else is happening on the server, right? What's going on in the other LPARs on that CPC, because I have those 3 dedicated IFLs there. And so that will allow me to work with that, test that environment, right? And so assuming the test results are good, then we're fine. Then we ship it off to the production environment and so forth. But again, this allows us to look at things. It also may be the scenario where once I run it in performance, I find that something breaks, right? Well, now I can ship those 3 servers back to CFT and let them debug that, right? And work with development and debugging that as opposed to having to recreate functional problems all the time on the performance system, right? So a little bit of sharing that environment there and giving me better control, right? Because it's the same database in this example in each one, right? It's not one that I'm going off on and using temporarily, right? Okay, that was a test one. This is one I added way back because it's one a client came up with that I found was interesting, right? Often I'm surprised, though I shouldn't be, that we'll develop something and our customer will find a use for it or a way to use it that I hadn't thought about originally. And so this was a client that had 2 production systems, 2 production ZVM systems, and then also a sandbox environment. Now, the 2 production systems were very discrete. There was really nothing related to one another in each of those. For all I may remember, it may have been a sort of outsourcing environment where those were actually 2 different clients that they were supporting in that environment there. So they didn't have a huge need for availability increases and for server sprawl, but they still wanted the benefit of being able to update more often the control program without having to take an application outage. What they did was they created 2 different clusters, a yellow cluster here and a red cluster, as I'm going to show them. And then they're going to utilize that middle sandbox there. Now, typically when they would run with what we call a singleton. That is a SSI cluster that has a single member running in the cluster. Right now, we're also going to configure or install 2 other ZVM systems. There's a second member of the yellow cluster, B2, which is second member of the red cluster. And then you're going to see how we utilize this. So what we're going to do is we're going to shut down that system programmer system in the sandbox, right? And we're going to bring up member A there, right? And so when that comes up, that extends that yellow cluster into the sandbox, right? And then allows us to do things there, such as moving the workload off of member A1, right? Shut it down, bring it back up, right? Move the workload back. So we're utilizing that sandbox as sort of a temporary holding place while we do this support. And then we could also do the same on the red cluster. I don't show all the steps there, but you get the idea. And in a way, the system programmers leverage this. They ended up getting a little bit bigger sandbox, right? Because they could say, well, we want a bigger sandbox there so that we can do these things. But instead of having 2 additional LPARs defined, they could get away with just having that one. And you can extend that. Maybe they have 3 or 4 members out there. They would just have these extra systems that were built on disk, but weren't typically running until they're needed for an exercise like this. Okay. So I thought that was kind of unique and a kind of clever way of addressing some concerns there without needing that full-time availability, right, of a second member. So this next one is a little bit of a DR scenario, or perhaps some would call more business continuity, but it's the idea that I'm going to have 2 sites or Perhaps they're just two different Z15 boxes out there, one where I'm running production, one that's a DR environment. And so I'm going to have two members that are active and running in my production scenario. Right? All the disk is perhaps getting copied over to the DR scenario with XRC or something of that nature. And there's two other members defined, but I never IPL them ordinarily. And so we'll say that something disastrous happens, right, on the production side where those members go down, the box goes down, there's a power outage, a flood, whatever it is. So in that process, we would sever the mirroring of the disk, at which point we could then bring up member C and D and be running things over there, right? Now, since the disk was mirrored, since it's part of a cluster, all the virtual machines exist that are in A and B can run in C and D. And so I could quickly bring it up. Now, it's not a high availability in terms of a automatically running, though I could build some automation around this, but it allows me to more quickly bring things back up from a business continuity perspective. Now, I don't go through all the steps here, but one of the things that we'll often talk about is you don't really have a DR plan unless your plan also includes how to get back to production. Right, so there might be some scenarios here where we reestablish the mirroring, but it's going the other way, right, to get things back there and then bring back up that member A and B after C and D go down. So you want to work through that as well. But this is sort of a way to get some advantages there. You don't have to have that Linux 1 DR scenario or site fully populated. There's different flavors of capacity on demand and so forth that can be leveraged there to exploit this. Okay, all right. So I have two little examples here that deal with performance in different ways that I thought were worth looking at. So this one is the scenario where I have two different machines here. The one on the left also has a ZOS LPAR on it. And let's say that I have hypersockets involved here, and I have some workload running there where that Linux 1 guest is getting a lot of advantage of DB2 over on ZOS. So I'm going over there, your hypersockets. Now, let's say maybe there's some month-end processing or something of that nature that Linux 2 is really going to be making heavy use of that DB2 virtual machine. Well, in that case, what I'm going to want to do is maybe swap those two Linux virtual machines around, right? So since they're both in that cluster between member A and B, I can move them around, either log them off and log them back on, or use LGR and allow that Linux 2, while it's doing its month-end processing or whatever's going on, to get the better performance of hypersockets, right? Because it would be in the same KEC where it couldn't get to the ZOS LPAR through hypersockets from member B, right? Can get that better performance from that perspective, okay? So some different little things like that. Now, that's kind of an extreme case that I would use there, but just kind of wanted to mention that as a different way of looking at it. Another one that's similar to that is this idea of perhaps doing some backup and restores or something of that nature, right? So kind of in my example here, maybe I have a Spectrum Protect server, right? So you know it as Tivoli Storage Manager. So that's running in member A. That's the server that's actually backing up or restoring what we're going to be moving data from. And maybe I have these two Linux virtual machines that have used that or are using that, right? Now, they could run just fine the way things are here, but we're moving things further through the network this way than if I were to just move the guest over so that it's closer to the Spectrum Protect. Maybe I have a fewer network hops to deal with this, or maybe I'm going over things like hypersockets or a vSwitch without going out to the physical network, right? And so maybe I want to do a backup and restore. I can do something like that, doing the restore this way, and then just move the guest back when I'm done with it. So again, kind of an extreme thing at scale. I don't know that I want to be moving my virtual machines around just for doing backups, but perhaps for restore or related DR kind of scenarios, that could come in handy. And this one I think we also showed earlier, but just want to walk through it again. So I have this idea that I want to bring in new Z15s, right? And so I'm going to have my 4 members here. For redundancy, I both have redundancy in my hardware. So I have 2 Z14s, but then redundancy from a software perspective, I have 4 members 2 on each of those Z14s. And what I'm going to do is I'm going to move workload from C and D up to B and A, right? Be able to do that, move those LPARs out of the picture, and then I'm going to take that Z14 out and bring in a Z15, right? So do kind of a push-pull on that, just recable things in the same spots, bring back up, remember C and D onto that new processor, right? Now I can move workload back into it, and I've updated the hardware on those virtual machines without stopping them. So I have had a number of customers that have done this, and I remember one saying that their developers on Monday morning said, "What did you do? Because the system's a lot faster than it was Friday." And they said, "Well, we upgraded your hardware." And they're like, "Well, we were up all weekend, so I don't know how you did that." They just said, "Well, it's the magic of IBM Z and Linux 1, right?" And then maybe I do the other processor the next weekend. I don't know that I'm brave enough to do both processors in the same weekend, but perhaps there are some people out there that would do that. Move workload back again. Now, if we recall back to the session we did about live guest relocation and relocation domains, for Linux to see some of the new capabilities, we might have to reboot them, right? But that's something we can plan and do appropriately. Also, another reason for why I wouldn't necessarily do both boxes on the same weekend, be able to do that for that. Okay. All right. All right. Well, as I told you, I thought this might be a little shorter since it's a subset, but I thought some material that was worth going over, right? So part of what I liked about this was that, as we talked about, SSI and LGR gives you new tools, new capability for dealing with resource and workloads, right? So while in the past, and one of the reasons why we didn't do LGR earlier was that we had a lot of capability in the hardware and in ZVM already to move resources around, right? So that we can move the resources to where they're needed, right? The fact that we can vary on and off processors, we can add memory dynamically, all of that goodness, right? Optimizing success, we talked in some earlier sessions about LGR, how it's more of a push model than a pull model, but that's primarily because of availability, right? If we were using a pull model for LGR where we sort of page fault things into the new system and we had a network outage, then we'd have 2 virtual machines, neither of which would run on either side, right? So we try to optimize. There's a lot of capability in the clustering to do that. And then we just want to protect that advantage, right? So we're going to not give up the capability that we've had in the ZVM system to do LGR. So goodness there. Well, I appreciate your time. Thanks, everyone.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.